Welcome to my video lecture on Basics of Signal and System. Myself Kiran Banerjee, Assistant Professor at Dr. Sudhir Chandra W. Engineering College. In my previous lecture, you have heard about the basics of circuit, and we have learned that different kinds of circuit, linear circuit, nonlinear circuit, network, and various kinds of network elements, those we have highlighted in the previous lecture. In this lecture, we will learn about the basics of signal and system. That means different types of signals and systems are also there, and basics of those we will highlight in this lecture. So here we will learn about how the signal and system of different electrical equipments can be there, and what are the basics of those signals, how it can be looked like a graphical structure and its characteristics, its mathematical formation. Those things we can see through this lecture. So first of all, what is signal? Basically, signal is defined as a function of one or more variables which provides information on the nature of a physical phenomenon. When the function depends on signal variable, the signal is said to be one-dimensional. For example, a speech signal whose amplitude varies with time depending on the spoken word and who speaks it. That means signal is basically defined as function of one or more variables which provides information on the nature of physical phenomena. That means signal is not a single quantity, it is combination of more variable functions, and these functions are dependent on two or more variables, and the signal is said to be multidimensional. Suppose example as 2D image. This is an example of multidimensional signal. Now we will go through system. What is system? A system is an entity that takes an input signal and produces an output signal. It is combination of interconnection of several components to perform the desired task. That means system is combination of input signal and output signal to perform a particular task. That is basically a system. That means a system can be run by using signals to definitely perform a particular desired task. The system responds to one or more input quantities called input signal, and it is also known as excitation, and to produce one or more output quantity, that is known as output signal or response. That means a system needs an input signal, then by getting that input signal it will perform some task, and from that after that performance it will give some output signal and we will get the desired result. Like that way, signal and system are basically working. That means signal and systems, they are just linked with each other. Without signals, there is no meaning of system. A system is invalid without the presence of signal. Now, what are the different types of system? Basically, there are 9 types of system is defined here, like continuous and discrete time system, fixed and time varying system, linear and non-linear system, lumped and distributed system, instantaneous and dynamic system, active and passive systems, causal and non-causal system, stable and unstable system, invertible and non-invertible systems. There are various types of systems are there, and I will highlight some important systems among these all different types. So first we will start with continuous and discrete system. The word continuous comes from continuation. That means it will represent something which is continuous. That means there is no gap between time and output. So basically signals are mathematically represented as function of one or more independent variables. We classify signals as being either continuous time, function of real valued variable, or discrete time, that function of interior valued variables. In other words, a continuous time signal has a value defined for each point in time, and a discrete signal is defined only at discrete point of time. That means these are the main important part. Continuous signal is continuous throughout the time. This is the time span, and here the signal is showing that is continuous throughout the time period. That means this is a continuous. And in discrete signal, it is a discrete type of signal where discrete points in time. That means these are the discrete points. These are not continuous. That at 0 point, the signal is here. At point 1, the signal is here. At point 2, signal is here, like that way. In discrete point of time, the signals are presented. Okay. So this is basically a continuous and discrete time signal system. Now next one is time invariant and time varying system. Time invariant, that means it is not varying with time, it is fixed quantity. Okay, and time varying means it is varying with time. After the time duration, the system will change. That is the main thing. A system is time invariant or fixed if the behavior and characteristics of the system do not change with time. A system is called time invariant or fixed if the behavior and characteristics of the system do not change with time. That means throughout the time, the nature of the system is fixed. So the system is called time invariant or fixed. The opposite part is time varying system. Definitely the system will vary with time. Mathematically, if the input is xt gives the output yt, then the system is time invariant. And if the input x minus t gives the output yt minus t for a delay of t, hence the time shift of the input gives the same time shift of the output. These are all examples of time invariant system. Okay. That means throughout the time it gives some certain fixed output. There is no variation with respect to time. Next one is lumped and distributed system. All the physical contain distributed parameters because of the physical size of the system components. For example, the resistance of a resistor is distributed throughout its volume. The resistance of the resistor is distributed throughout its volume. However, if the size of the component is very small with respect to the wavelength of the highest frequency present in the signal associated with it, then the system components behave as if it all were occurring at point. The system is said to be lumped parameter system. The system is said to be lumped parameter system. Distributed parameter systems are modeled as given below. First of all, it will be by partial differential equation if they are continuous time signal, and second one by partial difference equations if they are discrete time system. Okay, that means there are two things. First one is partial differential equation and second one by partial difference equation. So LAMS parameters are basically modeled with ordinary differential or difference equations. Here a small example is given like that. Consider an electric power system of frequency 50 Hz. The wavelength of the signal is obtained as n lambda equals to c, where lambda equals to c divided by 9n. That means 3 into 10 to the power 5 divided by 50. So it will be 6000 km. Thus, the electrical system inside the room can be treated as LAMS parameter system, but it will be treated as distributed system for a long distance transmission line. It will be treated as distributed system for a long distance transmission line. Okay. Now we are coming to some types of signals. Signals can be classified into different categories like continuous time signal and discrete time signal. Second, periodic signal, non-periodic signal. Third one, odd and even signal. Now first we will consider about continuous and discrete time signals. Signals are represented mathematically as a function of one or more independent variables. We classify signal as either continuous time or discrete time. Then continuous time means the function of real valued variables, and discrete time means an integer valued variables. In other words, continuous time signal has a value defined for each point in time, and discrete time signal has defined only for discrete point in time. I have already discussed previously these two. So similar types, continuous time signal and discrete time signal. Next, periodic signal and non-periodic signal. Periodic signal means the signal will continue throughout the period similar way. With the same periodic difference, the signal is moving similar way. Suppose a signal ft is said to be periodic if ft minus of ft plus minus nt, where n is the positive integer and t is the period. Thus, a periodic signal represents itself every t seconds. Some periodic signals are here given below. See, throughout the time, the difference is t, t2 to t, that means difference is t. Here, 2t to 3t difference t. And throughout the time, it is maintaining the same periodic nature. That means it is a periodic signal. A signal not satisfying the above condition is called non-periodic signal. That means if a signal does not maintain this kind of behavior, that its behavior is changed with certain duration of time. For certain time, it is ramp signal, after that it is behave like a sinusoidal or sawtooth or different thing, then it will a non-periodic signal. Example, some non-periodic signal like E dash or T exponential or time respect to that. Okay. So here we have discussed some very basic concepts of signals and some system. And in my next lecture, we will continue about the more signals related like sinusoidal signal or step signal, branch signal, like those things we will discuss in my next lecture. And you can go through the book of A. Chakraborty, Dr. M.G. Chakraborty of circuit theory for this chapter for reference purposes. It will be very much helpful. Thank you for listening my lecture.